Good morning, friends. We'll start Asme B 16.5 2020 edition, page 102. Table 3 is the permissible imperfection of flange facing finish for raised face in large male and female flanges. Table 16C, page 170. Dimensions of class 600 flange continued. So there are something I will just make you remember. Page 222. Table E4, dimension of class 1500 flanges. This flange fittings. Some more flange fittings, but this may be class different. Page 218. Some other classes, I think so. Or maybe same class. No, same class. The other diameters. Page 35. Pressure temperature ratings for group 1.7 materials. So there are some groups you have to find out from these numbers. Pressure temperature rating group 2.5 material. There is something written here, you see, not to be used over 1000 degrees centigrade, though allowed for temperature over 1000 use only if the material is heat treated by heating to a minimum temperature of 2000 Fahrenheit. If it is done, then you can increase this. Pressure temperature rating group 10 material. So let us start Asme B 16.5. The maximum depth and radial projection of an imperfection deeper than bottom this serration on NPS 14 raised face flange. The maximum depth. You see the first one. Here 0.18. That is the deeper than the maximum depth of imperfection. It is for 8, 10, 12, all 18, 14, 16 also. 8, 10, 12, 14, 16, all 0.18. So NPS 14 is 0.18. And NPS 24, 600 flange. Thickness of the flange minimum is 4 inch. So when you go to the top, this is the dimension. You can find the thickness. Minimum thickness of the flange 4 inch per 24. The allowable pressure PSIG in a 100 degrees Fahrenheit, 150, class 150. 8-inch flange made from A 182 grade F2 material. There is a table. Let's go to top. This is page 170, but the next one 222. This one the pressure temperature rating group 1.7 materials. So 182 grade F2 depends on what is the temperature you put here and the temperature here. How much you can use, and this is 290 for 150. (100 degrees Fahrenheit). (100 degrees Fahrenheit). 182 grade F2. In a class 1500 flange is made from A 182 F347 stainless steel. Used at 280 psi with carbon content 0.09. What is the maximum temperature can this flange be used? So there is a table. You can 182, 347. Pressure temperature rating 182, 347. You take the class and then you can find the temperature. Not to be used over 1000 degrees Fahrenheit. So that is because there is nothing written. It is heated above in 2000 degrees centigrade something. Heat treatment, nothing is written. So 1000 degrees Fahrenheit already in the beginning I shown that one. What is the minimum wall thickness of a class 900 flange? Oh, 900 NPS 16. So we'll go for fitting 900 class NPS 16. Is class 1500. This is I think 900 class. This got 1900. So 1.56. This is 900 class. Sorry. You will just write down. So this is 1.56. Don't have to. Let us see next. What is the rated working pressure of a flange fitting? That is 400 class. And the material stress value that I don't know how they're using 16 to 100. If from T they are calculating this, I don't know. Let's see. I'm just leaving for you because I don't want to spend time here. Just moving to the next one. The answer is 740. You try, then I will tell. What is it? Sorry. What is the minimum wall thickness of NPS 5 class 1500 fitting? The same, we can go to 1500 class NPS 5. You can see the thickness of the flange, thickness of the fitting. Thickness of the fitting 0.91. What is the maximum system hydrostatic test pressure required for a class 300 flange that which made of group 110 material? Just go for this group 110 material class 300, that's all. One one zero class 300, maximum 750. Let's see what is written there. And then hydrostatic test pressure. So you can 1.5. One one two five. That's it. 1.5 times the actual pressure you have to test. The local area has been thinned on a wall thickness of a flange fitting. The fitting NPS 8 class 400 and the local area has been thinned to 0.4. The corrosion acceptable. There is NPS only. Don't have to look for others. So 8 you see 0.24. So no, 0.18 I think so. No, area, local area. You have to go for local area. So let's see local area for 8. is 0.18. Okay, so that why not acceptable. What is the maximum circular area, sub-minimum thickness allowed in square inches? 0.31. Already seen. There is nothing more than that. Nine, 10 above. If two areas of sub-minimum thickness are observed on the fitting, what is the minimum distance between edges of these circles? There is another formula there. We'll see. In the fitting local areas, so area sub-minimum thickness can be enclosed by a circle whose diameter is no greater than 0.35 d into Tm, and then major thickness is not less than 0.75 Tm. Enclosure circles separated from each other by edge to edge distance more than 1.75 dTm. So d is the diameter, Tm is the minimum thickness. So 1.75 root over d. Eight NPS. Maybe 8.7, 8 point something, and 0.56, 3.7. What is the maximum system hydrostatic test pressure required for a class 600 flange? Joint made from good group 3.5 material. So 3.5 you can see class 300, 1500. Maybe here, maybe 3.5, class 300. So class 600. So class 600 is, I think maximum is 1500. That is what he is asking, maximum. The maximum system hydrostatic test pressure into 1.5 is 2250. Local area has been thinned on wall the flange fitting. The fitting is NPS 12 class 900. Local area has been thinned to 0.945. What is the minimum acceptable thickness for this thin area? It is the maximum permissible area acceptable. So minus this 0.9375. If the 1.25 is the actual thickness from the table. From the information question 13, What is the maximum circular area? 0.35 root over. That is 1.3. Root over dt. T is the thickness, d is 11.12. There is another table there. For wall of flange fittings, class 900. That you have to go. Class 900 flange fittings. And then you go for 8, you find this. Sorry, what is this? This is 12, then 1.25, then 11.12, like this. Inside diameter R of the fitting, D. So there is DTM. .52 is the answer. What would be calculated thickness for a new NPS 14 flange fittings of a 900 psi class designation? So NPS 14 you can find 1.38. Not 2.8, this is 3.8. And then NPS flange fittings operating at temperature 650 Fahrenheit and has a pressure rating of 600 psi. You have to find from 600 psi, bring out the thickness, the 650 Fahrenheit, this T, then you calculate P with this ratio. That's this stress value 1.5 PD by 2 SC. From the 600 plunge, you have to go 600 psi. Class rating 600. The rating 600. That is the problem. Then you puzzle everything. Class rating is 600, not PSI. It's fucking idiots. Okay, then we start. Some practice questions in Asme B 31.3. Again, these really small numericals you have to attend. What is the minimum wall schedule that can be used in a male threaded joint of normal fluid service, carbon steel, not sensitive, NPS 1.5 and smaller? Just we have to, there is something written. These things, small things, you have to remember. There is no other way. Yeah, yes. So for normal fluid service, 1.5 inch less than. So you go for 80 schedule, minimum schedule. 314.2.1. Carbon steel is generally considered to be not sensitive, whereas stainless steel is generally considered to be not sensitive. Determine the linear expansion in 100 foot of carbon steel pipe. So 3.16 from the 23 can go for bar. This here. Thermal expansion data. If 500 into 3.7, 400 2.8 lives. So for 450, you can calculate just between, in between. This will have calculate 3.25. They are writing 3.16. A 20-foot long carbon steel pipe is heated uniformly to 450 from 70 degrees Fahrenheit. Determine its length after heating. You go same table, you get some percentage for foot, some for that length for 100 foot, then for 20 foot, for 1 foot what, for 20 foot what, you can just calculate 0.065. It is coming. If a material carbon steel 18Ch 8Ni 18Cr not Ch 18Cr 8Ni, that is SS316 304 monoil aluminum heated from 70 to 550. Which one will expand more aluminum? And then here another two, we think. What is the example of straight threaded joint? Union comprising male and female ends joined with a threaded union nut. So what is the modulus of elasticity of carbon steel material? Carbon content less than 0.3 at 700 degrees Fahrenheit. Same if you go there is C6 moduli of elasticity of metal. You go here 0.3 or less and go for the temperature. When you find the E modulus of elasticity. I think 25,500. That is that one. Yes, 700 degrees Fahrenheit. If you check there, you can find 25.5. That means 25,500. 25,500 means I know 25,500, 100,000. They're just writing, so Poisson's ratio may be taken as 0.3 always. All temperatures. Stub valves are allowed on the inlet and outlet side of a pressure relieving device, provided they can be locked or sealed both the open and closed portion. A liquid thermal expansion relief device which protects only blocked in portion of the pipe system. The set pressure shall not exceed the lesser of the system test pressure or 120% of design pressure. It is only for this liquid thermal expansion relief device. only a blocked in portion of piping system. An STM 53 grade B pipe with maximum wall thickness of 0.75 inch. They are not giving this. If you go this, you get a curve from this elastic table. It's the tensile strength table A1, table A1, and then from the curve you will go to the. There is another table after the this impact curve. So that one you find is plus 15. We can go to so this is written relief device and all. So this is the clause for a liquid thermal expansion relief device that protects only a block in portion that is inside. That is a code book. So okay, next is this one. Tubular values of minimum temperature without impact testing. Curve A, curve B. So from where he is finding this is to go for the table, whether you follow the curve B, curve A. It is not shown here. Shown here 53B. I think so. So there is curve B. So from curve B, you go for that thickness. What thickness you have for that thickness is nominal thickness. You can find here what is the, or if curve A, what is the temperature. For lower exemption temperature. #53 grade B. So that may be A. So it is coming here. That is showing B, and thickness is 0.75. That one you have to go. For 0.75. This is for B. Curve B 0.75 is the Fahrenheit plus 15. So you have to go to find out. Each set of impact test specimens shall consist of 3. That is known. Everything in the code book I supplied it, so you can read it. A carbon steel who has joined my group, I had supplied it. A carbon steel ASTM A53 grade B being impact tested. What is the minimum energy requirement for this material? Is minimum 10 and average is 13. They're writing to two things. Answer is given to. In the exam may not be like this. Fully deoxidized steel. This is what fully deoxidized. And if you see put LBF, so average is 13. 65 KSI. How you know 65 KSI? KSI, then depending on this, you have KSI. The tensile 60 KSI, 53B. So from this within 65 KSI, it is 13 and 10. Average is 13, minimum is 10. Minimum only for 1. If not deoxidized, then other than fully deoxidized. A thicker wall pipe is joined into a thinner wall pipe. The thicker pipe is taper bored to facilitate the fit up where the maximum slope 30 degrees. These are as per code you have to remember. You cannot just go and find it each time. NPS 2 schedule 80 0.21812 is welded into NPS 6 schedule 40. What size of cover? Fillet 12 TC is points lesser of 0.7 TB. That is branch T of branch 0.1526. That is the answer. NPS 8 schedule 40. Wall thickness is given. HTMA 106 grade B was welded. Blah 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 blah. Preheat temperature. As a preheat temperature is there. Table is there. You go for that. It will give you 50 Fahrenheit. Visual impact test. Preheat temperature. See. So carbon steel less than 1 inch is 50. Greater than 1 inch 50. If carbon is more than 0.3, is 200. Less than 0.3 is 50. The zone for preheat shall be extended at least 1 inch beyond each edge of the weld. These things already in the code. You can remember this. ASME A106 grade B NPS2 schedule 40. This thickness pipe is to be welded to an ASME 335 grade P9. So you have to find out what is the temperature of A339 grade P9. Then you can find what is the temperature to preheat. Let's go for 15 now, I think so. This is P9. You see, 9 CR1 MOV. Nine CR1 MO A335 P9 is called like this 9 CR1 MO. 5B. So now you have to say this like this. 5B, 5B. You have to go for that. Even if you go here also, you get 400. That's all. Less than 60 KSI and more than 60 KSI. Less than equal to. The 300 or 400. That's all. You find out. The given answer 350. They make it 400. 300. Is up to you. Check it. When component of a piping system are joined by welding, the thickness to be used in applying the heat treatment provisions of Asme B 31.3, table 331.1.1. That is, the thicker component measure at a joint except certain exclusion. Thicker component is the answer. Sometimes they have certain exclusions. That's why they except for certain inclusion. Exclusion. That's NPS 4 schedule 40 branch connection is welded into this. Blah blah blah. Okay, then 0.7 of that or 0.25 lesser than 2. So you get this. There is header wall, this main wall 0.28, and then there is a reinforcing pad 0.25, and there is the branch that is welding. So total is 0.6959. Is around 70. And a semi 335 grade P9 NPS 8 schedule 40.322-inch wall pipe is to be welded to P9 NPS 8 schedule 40. What Brinell hardness? S241. There is a table in which I don't know, but 241 is the answer. I think table 11. I don't know how it is table 11. Maybe before was there. Now it is missing. Where hardness limit is specified in table 331.1.1. At least 10% of welds, hot bends, and hot form components from each furnace heat treated batch and 100% of those locally heat treated shall be tested. In ASME 335 grade P11, NP site schedule 125 is to be welded to an ASME 335 grade P9. NP site schedule 80 pipe. The Brinell hardness number is required after post-weld heat treatment. The grade P11 material must be 225 and P9 material must be 241. Like that. Flattening of bend, the difference between maximum and minimum diameter set in cross section shall not exceed 8% of nominal outside diameter for internal pressure. And if you go for external pressure, that is 3%. That is for external pressure, not internal. While assembling a piping system, it is required to pull two pieces into alignment. Disturb one of pieces, put a bend into one pipe section. The assembly is in a strain, that is, the inspector, since any distortion that induces a strain is prohibited. The details should be removed and the problem corrected. Before bolting a flange joint, the inspector should check alignment to the design plane. It should be within 160 inch per foot. Percentage, no, they had removed. Measured across any diameter. You can see before bolting, making gasket contact surface shall be aligned each other 1 millimeter 200 mm or 1/16th of inch per foot, measured across any diameter. There is no percentage. Flange bolt holes shall be aligned within 3 mm. Maximum offset. An inspector checking bolts and flanges find 3 bolts in an NPS 6 300 class flange, but will not meet SME 31.3 bolt length specification. What is fine? Lack of engagement or half engagement into threads. That's how. The 300 class has 5 holes. Now it is. No, this is the answer. They still not. Okay, 3 bolts, not. Then if through bolt, then three. Lack of engagement was 2 threads. Okay, lack of engagement was 2 threads. They have the required holes. Okay, I thought in a different way. Okay, so it is inside 2 threads. You find a flange joint as per Asme 31.3. It should be total cover. It should cover total threads. You find a flange joint with 2 fiber gasket used in a makeup the joint. What is the correct course of action for an inspector? So remove 2 gaskets are unacceptable. The joint should be repaired to take only 1 gasket. Inspector find incomplete penetration in a radiograph of a girth weld, normal fluids piping. What can he accept, or can he accept an incomplete penetration? I don't know, this may be before, it is changed now. This one. Incomplete penetration. There is B for girth weld, miter groove, branch connection, normal fluid. There is no girth. There is a severe and category D. So here is, you see girth is B. When B is cumulative length, it is 38 millimeter in any 6-inch weld length, 25% the weld length, whichever is less than equal to 38 or 25. 25%. I don't know if undercut and all. Maybe undercut. They write something else. I don't know. I put in the incomplete penetration zone. This is all wrong. When spot random examination reveals a defect, what should the inspector do? It reveals a defect, so take two additional samples for the same kind used for the first examination. If they are acceptable, repair or replace the original defect and accept the job. Prior to okay, we'll stop here.